Once let me start recording. Okay. So previous class, yes, it just basic started. Yes, about ways discussed, right? What is operating system discussed? That ways part up to that ways part discussed. Next, Java is a application software. Java is a application software. See, let us move to application software. See, application software. In application software, yes, two categories. This is front end and back end. So front end, back end. What is front end? What is back end? Let us see. Front end. See here, this is some form, some registration form, right? Here is a registration form. So here some registration form, right? Yes, in this, just we are filling form and submitting, right? Yeah, this is called as front end. So this is front end. So form taking your data and storing at some location. Yes, storing some location, storing at some location. That location is called as backend. Okay. So front end once. Let me take some more. Yeah, this form is a front end. This form is a front end. So this front end interact with end users. Front end. So this is front end. So front ends interacting with the end users. This one interacts with end users. Okay, taking data from users and stores in backend. So what is backend? Backend is to store and maintain data. That's a good fine. Okay. So front end, yes, to interact with end users. It collects data from end users, stores in the backend. So what is backend? Backend is to store and maintain data. That's it. Okay, right? Yes, Java comes on front end. So let us move to front end. In front end, yeah, there are languages and packages. Front end language and package. Yes, package ready-made one ready to use. For example, MS Office package. Ready-made available all the options here like file, home, insert, all predefined options. Ready-made one ready to use. So using this one, we can prepare documents. Okay, fine. Java comes in languages. Languages, not languages. Let us say about language. Java is a language. Okay, so what's a language? Yes, see language. So what is language? See language, just it's a media of communication. What is language? In simple meaning, it's a media of communication. Language is a media of communication between two living things, maybe two persons or two animals, two trees. Just media of communication. Yes, come to software fields. In software field here, yes, computer understanding some language. Yes, in software fields, computer understanding some language. Yes, computer understandable language. Julius funds format. Julius funds format. This is called as binary code. This code is a binary code. It's a binary code. It's a binary code. Julius funds format. It's a binary code. Julius funds format. Just it's a binary code. It's a system understandable language. Binary code. Binary code. It's a system understandable language. Binary code. Okay, this is binary code. Okay, Julius funds format. It's a binary code. Okay, so this is a computer understandable language. Computer understandable language. It is a binary code. It's a binary code. Okay. Yes. 1 second. 1 second. Hello. Yeah, I'll call back within an hour. Yes. So this is binary codes. Yes, it's a computer understandable language. Yes, it's a machine language. This is called as machine language. It's a computer understandable language. Next, another one. Yes, see here, computer understanding this language. Next, our language different. Our language like English language. See, for example, here, yes, let us take some Java program. Suppose some Java program. Test. Suppose some Java program, right? Here this is like a English language, right? It's a user understandable language. Yes, like English language, Java program, or Python program, or C program, or C++, or all looks like English language. Those are English language, just like English language, right? User understandable. User understandable, right? So these are user understandable. Yes, user understandable language, like English language. Okay, right? Fine. Now here, binary codes. It's a system understandable language called as low level language. Next, user understandable called as high level language. So in software, languages are basically two categories. First one, yes, low level languages. Low level languages. First one, low level languages. Second one, high level languages. Second one, yes, high level languages. Low level and high level languages. Low level and high level languages. Okay, first one, low level languages. First one, low level languages. Second one, high level languages. So what is low level language? What is a low level language? What's a low level language? So low level languages and high level languages. So what is low level language? What is high level language? Let us see. Low level language. Low level language. Yes, it is a system understandable language. It is a system. Yes, it is a system understandable language. A system understandable. It's a system understandable. Understandable. Yes, it's a system understandable language. Okay, it's a system understandable language. It's a system understandable language. Okay. Yes, what is low level language? It's a system understandable language. It's a system understandable language. Yes, it is in the form of binary codes. Binary codes. Okay, today I'll show binary code also. Today we'll discuss the topic also. Binary code also I'll show. Okay. Yes, low level languages. Yes, it's a system understandable language. System is here computer. It's a computer understandable language. Computer. It's a processor. There's a processor understandable language. Processor understandable language. Okay. Low level languages. Low level language. Low level language. Yes, it's a system understandable language. System understandable language. It is in the form of binary codes. Binary codes. Like binary code, like the zeros ones format. Binary code called a binary codes. Okay. Yes, it is called as. Yes, it is called as machine language. 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 So that low level language, system understandable language, it is called as machine language. Okay, right? It's a machine language. Next, high level language. High level language. High level language. So what is high level language? Yes, it's a user understandable language. Yes, it is a user understandable language. It's a user understandable language. User understandable language. It's a user understandable. High level language. It's a user understandable language. Okay. So low level language, it's a system understandable language. High level language, it's a user understandable language. User understandable language. Yes, it is. It is like English language. It is like a English language. It's like English language. Like English. Like English language. It is like English language. Like English language. It is like English language. Like English language. So high level language. High level language, it's a user understandable language. It is like English language. Looks like English language. Okay, so this is like a yes, like English language. Okay, right? It's like English language. Okay, like C program, C++, Java, HTML, Python, all are high level languages. All are high level languages. C is a first to high level language. Developed in the year 1972. C is a first to high level language. So before C language, we have the machine language. Zero response format. Machine language. Machine language is a first language. In computers here, machine language is first generated. It's a first language. Later, all the high level language. In high level language, C is a first to high level language. First is C language. Later, C++. Next Python. Next Java, like that. Okay. So about low level and high level languages. Low level, high level languages. See, high level language, see like Java program. is a high level language. C program, high level language. Python codes, high level language. HTML, high level language. But system can't understand this code, right? System cannot understand here. System can't understand this code. System can't understand this code, right? Now this code has to convert into binary codes and submit system. This code, yeah, this program, this code has to convert into binary codes. This code has to convert into binary format. This code has to convert into binary format and submit to system. Yes, who will convert into binary format? Who will convert into binary format here? For this, either interpreter or compiler. Either interpreter or compiler converts from high level language to binary code. Either interpreter or compiler. Interpreter or compiler converts from high level language to binary codes. Yes, interpreter, compiler. What is interpreter? What is compiler? Let us see that. Interpreter and compiler. Okay. Yes, interpreter. Yes. Yes, interpreter. Interpreter versus compiler. This is important point. Yes, interpreter versus compiler. Interpreter versus compiler. So what is interpreter? What is compiler? Let us see. Okay. Yes, interpreter versus compiler. Okay. Yes. To understand JVM topic, you must have interpreter and compiler knowledge. So interpreter versus compiler. So how interpreter working and how compiler is working? Let's see. Okay. So before going to Java concepts here, what is interpreter? What is compiler? Let us have a discussion on this. Okay. Yes. Interpreter. Suppose let us take some interpreter based language. Interpreter based language about test.py Python script. Python script. Let us take Python script. Suppose Python source code. Suppose source code. That source code program. So test.py. Okay, Python script. Let us take one Python script. Yes, Python. Yes, it's a interpreter based language. Python is a interpreter based language. Let us take some Python code. Some Python script. 1 second. Python D drive. Yes, enter Python folder here, Python script, some test.py file is available. So let us go to this D drive enter Python. Yes, D drive cd backslash c exit source cmd command prompt here open like this. To go to D drive D colon, that will take you D drive. Okay, here yes, in this enter Python is a directory folder, both are same. Yes, directory folder both are same. Directory change of directory cd yes mn Python, right? Changed cls clear screen dir. Yes, here they say test.py file. Here they say test.py file, Python file here. Yes, notepad. Yes, test.py. Right. Okay. See here, a equal 10, b equal 20, c equal to a plus b. Print addition equal to next c equal to a minus b subtraction. Simple program. How this program is working here? How this is working here? See this Python script directly running. Python just I'm running directly here. It's working directly. Suppose if it is C program, generally C program first of all check for all errors, right? First the compilation. If it is C program, yes, C is well known for you generally here. Okay. C language, C program. First you have to compile it. If no errors, then running, right? First of all, you have to compile the C program. First compiling C program. After compiling C program, if no errors, then submit, then execution, right? But in Python here, directly running program. Yes, error checking not required here. Directly submission here. Source program executing directly here. Directly program submission. Program executing directly here. Program executing directly. Okay, program submission directly here. No checking for errors. Errors checking not necessary. Suppose if it is C program, First you have to compile it. If no errors here, then execution, right? C is a compiled based. Yes, compiled based we'll see next. Now interpreter, yes, no errors checking, directly executing. Interpreter based program will execute directly. Suppose, for example, here some errors, some mistake here, some mistake here. Okay, some mistakes. There are two errors in this CLS. Okay, now yes, run it here. Yes, here stop it, right? Here will stop it. Yes, here addition equal to C. Here error message simply stop it. So what is happening here? Let us see what is happening in the interpreter based language. What is happening in the interpreter based language? Maybe Python, maybe HTML, maybe shell scripting. Various scripting languages are available. Different interpreter based languages available. So what is happening here? Interpreter, how interpreter working? How interpreter is working? Let us see how interpreter is working here. Okay, see here. Suppose this is your code, program code, maybe Python code, or some interpreter based language. Suppose this is Python code. For example, this is Python code. Yes, Python code. Python code. Suppose first statement, next statement. Okay, next statement. Python code. Next statement. Okay, next statement. So next statement. Okay, Python code. Next statement. Yes, next statement. Next statement. There are some statements here. Okay, so how this is working here? How this code is working? So next statement, Python code or any scripting language. Any scripting language. Yes, interpreter based language. All scripting languages are interpreter based language. Okay, so how interpreter working? How interpreter working on this? How interpreter working on this? See, first of all, interpreter checking first statements. If first statement is correct, if statement is correct here, the statement simply just converts into binary format. Binary format and submit it to processor. Just submit it to processor. Submit it to processor. Submit it to processor. Now processor will generate output here. Submit it to processor, generating output. Okay, after checking first statement is correct. Immediately converts into binary code. Submit it to processor, generating output, right? See, next statements may be right or wrong. Okay, next statement may be right or wrong. It won't think about next statements. Yes, interpreter never think about next statements. Interpreter never think about next statements. Suppose if that statement is correct, if that way statement is correct, immediately converts into binary code. If statement is correct, immediately converts into binary code and submit it to processor, generating output. Yes, after that, checking for next statements. Checking for next. Suppose next statement also correct. Yes, even this also converts into binary code. Next statement also converts into binary code. Same. Yes, submit it to processor. Submit it to processor. Next generating output. Generating output. Correct. Yes, checking for next statements. Checking for next statement. Suppose next statement something is wrong here. Next statement something wrong. Simply stops. Something wrong stops. See here. Yes, in this program. See here. This Python script here. Test.py. So here error. Next here one more error. There are two mistakes, right? Two mistakes. Okay. So this statement checked. After checking, yeah, this is correct. This is correct. What happens here? Memory allocating for A, then storing 10. Next, this statement checked. Yes, this also correct. This also correct. So memory allocate for B and store 20. C equal to A plus. This also correct. So this also performed. Yes, this addition also completed. After here, yes, error simply stop. Here it says stopped. Okay, whenever once error comes, simply stopped. Yes, even it won't check for next error, next coming error. No. If any error comes, simply stop there only here. It won't go to next statements. It won't go to next statements. Suppose same thing if it is compiler, compiler shows all the errors. First error here and second error here, 2 errors. Compiler shows all the errors, but interpreter is only first error. Interpreter shows only first error. So first statement checking, correct, execution. Second statement checks, correct, then execution. Next statement checks, correct, then execution. Next statement, something wrong, simply stops. Simply stops. It won't go to next statements. It won't go to next statement. This is working of interpreter. Yes, compiler also, I'll show one practical example. Compiler also will see here. Okay, so how interpreter is working here? Checking first line, checking first line. If first line is correct, if first line is correct, simply converts into binary code. Checking first line. If first line is correct here, simply converts into binary code. Converting into binary code and submit to processor. Checking first statement. If first statement is correct, converts into binary code and submit it to processor, getting outputs. So first statement completed. So first statement is correct, completed immediately here. Okay. Next statement checking. Next statement also correct, execution will complete. If statement is correct, immediately execution also will finish. Okay. Suppose any error, simply stops. Any error, simply stops. Yes, it won't go to next statements. Suppose next statements, any errors are there, it won't show next errors here. Only first error. If first error, for the first error stops here. It won't go to next statements. Okay. Any error comes, simply stops there. Any error is there, stops. This is working of interpreter. So how it's working? Line by line. Checking first line and executing immediately means first line completed. Next checking second line, then execute second line is also completed. So line by line. Line by line. So first line checking completed, second line checking completed. So line by line. Yes, suppose any error, simply stopping. Any error, simply stopping here. That's it. So this is interpreter. Next compiler. How compiler working? Let us go compiler here. How compiler is working here? Let us compiler. How compiler? Let us see about compiler here. Compiler. How compiler is working here? Compiler. How compiler is working here? Suppose test.c program. Let us take some C program. Test.c program. Test.c program. Linux base. C program on Linux base. How that C program working? We'll see. Yes. Yes. A compiler. How compiler works here? Let us see about compiler here. Compiler. See, compiler checks the first statement. Suppose first statement is correct. Even it's correct here, it won't convert into binary code immediately. It won't convert. It won't convert. Checking for next statement. Next statement correct. Even correct, it won't convert. It won't convert. So what happens in case of compiler here? Compiler first of all checks the whole program from top to bottom. Compiler checks the whole program from top to bottom. So first of all, compiler checks whole program from top to bottom, checking for all statements from top to bottom. Okay, so first statement is correct. Next, go to next statement. Next statement correct. Go to next statement. Suppose something wrong here. Yes, compiler shows that error at some line. Error at some line. After that, checking for next statement also. Even error comes, go to next statement also. Checking for next statements. Suppose next is correct. Then checking for next statements. Next is correct. Then checking for next statements. Okay. Suppose something wrong here. Something wrong. It shows error. Error at some line. After that, checking for next statement also. Checking for next statement also. So next statement also correct here. Then checking for next statement like this, top to bottom. Checking for all the statements from top to bottom. Checking for all the statements from top to bottom and shows all the errors. So compiler checks whole program from top to bottom and shows all the errors. Top to bottom errors, right? In case of interpreter, what happens here? For the first error stops. For the first error stops. For the first error stopping, it won't go to next statements. Next statements. But in case of compiler, what happens here? Compiler checks the whole code from top to bottom. Compiler checks the whole code from top to bottom and shows all the errors. And shows the all the errors, right? No. As a programmer, you have to correct all the errors. Yes. Errors correction. Yes, after correction of your syntax. Correction of syntax. After correcting syntax here. Correction of that program syntax here. After correct syntax and some rules. Syntax and some rules. Correction. Yes, after correction here. After correction recompile. Next time no errors. Everything is fine. Next time no errors. Everything is fine. If everything is fine, what happens here? If everything is fine here, if no errors, then compiler opens one more file. If no errors, then compiler opens one more file. Compiler opens one more file here. After opening another file here, this whole code, that compiler whole code, maybe C program code, that whole code converts in binary format and write to another file. Binary format, write to second file, another file here, write to another file. That whole code converts in binary format and write to another file. Yes, write to another file. Whole code converts in binary format, write to another file. Just writing to another file. Just writing to another file. This file is called as exe file. This file called as exe file. So what is happening here? Compiler checking whole code from top to bottom. Compiler checking whole program from top to bottom here. After checking, if no errors, generating one exe file. The source code program converting to exe format. Yes, I'll show now. What is exe file? I'll show. So converting into exe file. After generating exe file, this exe file submitted to processor. Now processor taking that exe file. So at a time, whole code submitting at a time. See, previously, first line checking, interpreter first line checking, correct. Submitted first line. So first line completed. Second line checking. Yes, correct. Submitted to processor. So completed. So line by line, right? But what happens in case of compiler here? Checking all the lines from top to bottom. If no errors here, generating one exe file. That exe file submitted to processor. So processor taking that exe file just executes on generating output. So at a time executing. So the interpreter based program is line by line. It's line by line executing here, but compiler based one exe file generates at a time. Yes, at a time executes and giving output. Okay, at a time executing and generating output. So this is difference. Yes, let us go to C program. That compiler, how compile is working here. Let us see how compile is working. Just a minute. Yes, Linux login is done. This is Linux terminal. Yes, present working the PWD present working directory demo ls it contains. Yes, here's some mnraw directory cd and mnraw change of directory present working directory mnraw ls. Yes, remove star all the files were removed here. Present working directory mnraw ls. Okay, now let us write one C program. Gedit test.c program. Okay. Yes, in this same that Python script, same Python addition, subtraction, multiplication, same in C language. Hash, yes includes, hash includes std io.h, hash include std io.h. Next white main method, main function. Yes, main function is int a is equal to 10. Next, yes, int b is equal to some 20. Right? Yes, next int c, int variable c, right? Yes, int variable c. Yes, a equal to 10. Yes, b equal to 20. Next int c, right? Now c is equal to here a plus b. C equal to a plus b, right? Now printf. Yes, in C language, printf is a function to display output on the screen here. Printf addition. Yes, addition. Yes, addition is equal to %d, %d. Yes, slash n to take to next line, comma, so displaying C value. Fine. So this is addition. Okay. Next, similarly, subtraction. C equal to A minus B. C equal to A minus B. Subtraction. Subtraction. Yes, subtraction. Yes, subtraction. Subtraction equal to C value. Okay, right? Next, multiplication. Same C I'm using for 3 operations. Okay. Yes, we can use. Yes, C equal to A into B. Multiplication. C equal to A into B. Yes, multiplication. Okay. So multiplication equal to. Yes. Multiplication. Multiplication equal to. So displaying C value. Next, close main method. Okay. So hash include std data wide main int a equal 10, b equal to 20, yes, a equal 10, yes, b equal 20, int c, yes, result variable, c equal to a plus b, addition equal to displaying c value. Next, subtraction, c equal to a minus b, subtraction displaying c value here, subtraction, next multiplication. So this is program, right? Save, control s, save. It's notepad, like a Windows notepad. Save. After saving, now compiling C. Yes, after saving ls, see this. As in working directory, m enter ls in this test.c program is there. Test.c program, right? Now let us compile this. cc-c test.c. So this is compiling C program. Yes, compiled. Test.o file got it. Yes, it's a .o means object file. Object, this object file contains binary code for your C program. Binary code for C program. Yes, after what is next step here? CC -o. That object file which we should convert into exe file. Suppose some exe name is project test.o. So now the test dot the object file converted into exe format. Exe format. Ls. The project exe got it right. It's exe. The green color is exe file. Now we got project exe file. You see exe file. This project. Run it. Listen. Subtraction. Okay. See, 1 second. This is a turbo C blue screen. In C language, just 1 second. In C language, turbo C also installed in my system. C language. See, actually, this is here. This is using this learning rate. Maybe in your college. In your college. Yes, in your college, maybe use this one to learn C language. Okay. Something like this. Some programs like this, right? Maybe learn like this. But actually here this is only learning purpose, only for learning purpose. But in real time, Linux based C language, Linux based. So what are the steps in this? First, we should compile it. Yes, compile it. After compilation, generating one tested .to file. The .to file convert into exe file. Next, we should convert into exe file. Yes. So project is a result exe file. Project is a result exe file. I from its object file. Object file converted into exe format. Exe format, exe file. Now project is a exe file. Now dot slash project. Project exe file. Right? See addition, subtraction, multiplication. Got it right? So what's happened here? Checking for errors. Checking for errors. If no errors, you're generating one exe file. That exe file executed. Okay. Suppose there are some errors. What happens here? There are some errors. Suppose some errors in the program. What happens? Yes, let us make some mistake here. Suppose semicolon missing here. Suppose here double quotation missing. Okay. Suppose here comma missing. Okay. Suppose next here. So this double quotation missing. So what happens? Let us see. Save and compile. Yes, cc -c test.c. Right. See this. Showed all the errors from top to bottom, right? Yes, all the errors. Error at 10th line, error at 12th line, 4th line error, 22nd line error. So top to bottom, compiler checks whole program from top to bottom and shows all the errors. See, compiler checks whole program from top to bottom and shows all the errors. But in case of interpreter, what happens here? Interpreter checking line by line. Okay, suppose any error can simply stops. It won't go to next statements. Yes, next statement, even next statements are errors, it won't show next errors. Only first error shows here. Only first error. See this interpreter based language. Only first error notepad. See here. Suppose here mistake. Here one more mistake. Suppose here, well, let us make one more mistake here also. Okay. Yes. 1, 2, 3. Three locations error. Three locations error here. Three locations. Now here directly submitting Python script that interpreter based language directly submitted. Only first error. Seventh, only first error showed, right? Simply stop. If any error comes, stops. It won't go for next coming statements. It won't go to next coming statements. It simply stops. Just stopping the run. So working of interpreter. Interpreter shows only one error, but the compiler shows all the errors from top to bottom. Compiler checks whole program from top to bottom and shows all the errors. Now let us correct that mistakes here. Correct stuff for errors. Suppose semicolon here missing here. Okay. Yes. Save 1 second. Yes. Let us compile this again here. Compile. See now error. 14th line error. See the statement missing right here. Exact location error here. Printf here. Double quotation missing. This is. So here is missing, right? So here missing. Okay, right? Yes. Next here this is missing here, right? Missing double quotation terminating character. Double quotation missing here. Okay. So this line. Okay. Yes. Now. Double quote. The double quote, right? Yes. Here it's missing. Save. After saving. Now recompile. cc -c test.c test.c. Yes. Recompiles. Now again one more error. 80th line error here. Yes. Here this is missing here. Here after double quotes. Here missing means comma missing here. Before brackets. Something missing. So that comma missing here, right? Yes. Like this you have to correct one by one error here. Yes, here comma missing here. So next here double quote missing. Okay, fine. Save and close. Yes, after that here no cc -c right test.c. Yes, compile right. 1 second. Remove please. Yes, remove project file. Yes, remove dot set dot file removed. Only test.c program is there. Test.c program. Now compilation. Yes, compiling cc-c test.c compiles. Test.o file generated. Now this is converting to exe format. cc-o. That exe name can be anyone. Exe name, some xyz dots, no issue. Test.o. Test.o. See xyz exe file generated. Now /xyz. Right. What the output? Okay, what happens here? So finally, compiler converts whole program into one exe format. If no errors, then finally getting one exe file. That exe file submitted, then execution, right? Execution. So this is difference between interpreter and compiler. So compiler checks the whole code from top to bottom. If no errors, generating one exe file. Suppose if any errors, it shows all the errors. Compiler shows all the errors from top to bottom, but interpreter shows only one error. Any error comes, simply stops. But compiler shows all the errors from top to bottom. Suppose if no errors, generating one exe file. What is exe file? We'll discuss. I'll explain exactly what is exe file. I'll explain that point also. Yes, exe file. Generating one exe file. That exe file submit to processor. So processor taking exe file, then executing generating output finally here. So exe file is a machine language. It's a system understandable language. That exe file can system understandable language. Okay, 1 second. So this is yes interpreter and compiler differences. Let us see all the points here. Yes, let us see points wise discussion so that you can understand clearly. Yes, interpreter. Next compiler, interpreter and compiler. Okay. Yes, interpreter versus compiler. Yes, how these are working here. Let us see the differences here. First one. Yes, interpreter. Yes, it checks the code. Yes, it checks the code line by line. It's line by line. Okay, checking code line by line. So interpreter checks the code line by line. Interpreter checks the code line by line. Yes. What is the compiler? How it's working? Whole program. Yes, whole program. Yes, from top to bottom, from top to bottom, from top to bottom. Whole code from top to bottom. Okay. So interpreter checks the code line by line. See interpreter, how interpreter working? Interpreter checks the code. Interpreter checks the code line by line. So interpreter checking code line by line. Interpreter checking code line by line. Okay. Yes, when come to compile here, whole program from top to bottom. So interpreter checks the code. Interpreter checks the code line by line here, but compile is whole program from top to bottom. That's first difference. Next difference. Yes, interpreter generates output. When come to output here, it generates output line by line, line by line, line by line output. First line checking, if it is correct, generating output. Next line checking, correct, generating outputs. But in case of compiler generating one exe file. After generating exe file, that exe file executes and giving output at a time, right? So this is at a time output here. So at a time output here, at a time output. So at a time generating that output here. So interpreter is line by line, but compiler at a time. That whole code submitting at a time here and generating output at a time. Okay, fine. Next here, yes, interpreter shows only one error. If any error comes, stops. So it shows only one error. It shows only one error. It shows only one error. Compiler all the errors, all the errors from top to bottom, from top to bottom, from top to bottom. Shows all the errors from top to bottom. Yes, compiler shows all the errors from top to bottom. Okay, fine. Next, main difference. Main difference between interpreter and compiler. Exe file. Exe. See, in case of interpreter here, line by line converting and giving output immediately, but don't have any exe file. But in case of compiler, exe file generating, right? See here, Python scripting here. See in Python, yes. So error. Yeah, this is done. Next, this is okay. Next here, save. Now directly source code submitting directly here. No exe file. The source code executed directly here. So interpreter it executes source code directly here. No exe file. So interpreter does not generate exe file. So next, one more difference. Interpreter never generate exe file. Yes, it does not. Yes, it does not generate. It does not generate. This is the main difference. It does not generate exe file. Okay. Yes, it generates. Compiler generates exe file. It generates exe. This is the main difference. It generates exe file. It generates exe. This is the main difference. So main difference between interpreter and compiler. Yes, interpreter based language don't have exe file. Interpreter never generating exe file. Directly source code executes. Compiler based exe file executes. Yes, compiler based generating one exe file, that exe file executes. Okay, fine. So interpreter, yes, it executes source code directly here, source code directly. No exe file concept here. It executes source code directly here. It executes source code. Source code means your program. That's your program. It executes source code directly. Compiler, yes, it executes exe file. Generating one exe file, executing exe file. Okay. So you can next step. So this is main 4 and 5. These 2 points are important here. So interpreter does not generate exe file. It executes source code directly. Compiler, it generates one exe file and executes exe file. Yes. See interpreter. See all scripting languages comes in that. Yes, interpreter based. All scripting languages. Compile based. These are programming languages. Compile based programming language. These are programming languages. They are programming language. Yes, all programming language. The scripting language examples. Here. Examples. HTML, hypertext markup language. HTML, hypertext markup language. Yes, for HTML, browser is an interpreter. Yes, HTML is a browser understandable language. HTML is a browser understandable language. Yes, suppose this is browser, right? browser understandable language. Suppose some HTML code. Let us see HTML code also. Suppose here HTML, see test.html file. Some test.html, open with notepad. See, it's HTML code, right? It's HTML code. Like login, user ID, password, and submit button. Login script. Double click on it. Yes, open directly. Yes, it's open browser, right? It's a browser understandable code. HTML is a browser understandable code. HTML is a browser understandable. Yes, browser is an interpreter for HTML here. For HTML, browser is an interpreter. Browser is an interpreter. Okay, fine. HTML, next Python. So Python interpreter takes care of Python script here. Next shell scripting. Linux is a shell scripting. Shell is interpreter. Shell is interpreter. Yes, in Linux, shell interpreter. Linux. Yes, in Linux here. Linux. This is a shell scripting. Shell scripting. Suppose math dataset. It's a script file. grich. Yes, math dataset. The script. So this is shell script. The shell script. Like a Python scripting shell script. Now shell script, this will execute directly here. No exe file. Bash. Yes, first number, second number. Yes, next. So one for addition like this. So directly executed. It's a shell scripting. Just scripting this is directly execute, no exe files. So directly executing that script, right? No exe file. Don't have exe files. Okay, right? Yes. Shell script. HTML, Python, shell scripting. Next one more example, PHP. Next Perl scripting. Okay. And JavaScript. JavaScript also interpretable. JavaScript is not a Java. Java is different. JavaScript is different here. JavaScript is a browser understandable language. JavaScript is a browser understandable. Java is a JVM understandable language. JavaScript is a browser understandable language. Okay, Java is a JVM understandable language. JavaScript, where JavaScript is in here? Yes, this is from client side, Java server side. Suppose for example, Facebook application. In Facebook application, yes, uploading data from your mobile, right? Yes, your mobile is a client. In your mobile, JavaScript will run. Your mobile browser, yes, in your mobile browser, JavaScript running. That JavaScript taking data from you and upload to server. At the server side, Java. That Facebook application developed in Java, but your mobile browser, JavaScript taking your data and posting the server side. At server side, Java program taking data and storing one database, right? That's it. So JavaScript is client side, Java is server side. Okay. Yes, your mobile is a client. So in your mobile, JavaScript running here. Yes, Facebook application is server. At server, Java. That's a different. JavaScript is not a Java. So JavaScript is not a Java. JavaScript is a, yes, JavaScript is a browser understandable language. Java is a JVM understandable language. Yes, next for this example. Yes, programming languages. Compatible with C language, C++. Next, .NET, C#. These are compiler based. So these are interpreter based languages. These are compiler based languages. What is Java? That is our topic actually. What is Java? Is it interpreter based language or compiler based language? Okay, that we should decide it. Java, yes, is it interpreter based or compiler based? That we should decide it. Yes, for that I'll explain one. Yes, I'll explain that Java, how Java is working, then you decide it. First, let me explain how Java is working, how Java program is working here. I'll explain about Java program. After that, you decide it. Okay. Yes. Next one here. Next one. See here. Yes, interpreter-based language. Interpreter. Yes, interpreter-based language. Interpreter-based language. Yes, interpreter-based language. Yes, don't have exe file. Don't have the exe file. Yes, next difference. Interface-based language, interpreter-based language don't have the exe file concept. Don't have exe file concept. No exe file concept here. Okay, interpreter based language don't have exe file concepts. Yes, when come to programming language here, compiler based, here everything is exe file. Everything is an exe file. First exe file generating, then execution. So runtime always exe file. So exe file, but interpreter based source code executing directly here. No exe file concept. Interpreter based language don't have exe file concept. Yes, compiler based language, everything is exe file. Always executing exe file. So this is difference between interpreter and compiler. So interpreter checks the code line by line. Yes, compiler whole program from top to bottom. Next interpreter output line by line output here. Compiler at a time because exe file. At a time submitting and generating outputs. Next interpreter shows only one error. It shows only one error. But compiler shows all errors from top to bottom. Compiler shows all the errors from top to bottom. Next interpreter, it does not generate exe file. Yes, no exe file. Compiler generates exe file. Okay. Yes, in case of interpreter, it executes source code directly. See, interpreter, yes, it does not generate exe file. It executes source code directly. But in case of compiler, first it's generating one exe file, then executes that exe file. Okay. Yes, interpreter based languages are called as scripting languages. Interpreter based called as scripting language. Compiler based called as programming language. Programming language. See, interpreter based language examples. The interpreter based HTML, Python, these things. Next, they are programming language. C, C++, .NET, C. Next, one more thing. Interpreter based language don't have exe file concept. Compiler based, everything is exe file. Now, let us start Java. Now, what is Java here? Question is next question. What is Java? So, what is Java? What is Java? Yes, is it? Yes, interpreter based, interpreter based or compiler based? What is Java? Yes, is it interpreter based? Is it interpreter based, based or compiler? That's the question here. Okay. Yes, is it interpreter based or compiler? That we should ask this. So what is Java? Is it interpreter based or compiler based? What is Java? Is it interpreter based or compiler based? Let us see this. Yes. See, except Java. See, in other languages, what happens here? Other languages like C language or C++, maybe Python, maybe HTML, except Java. In other language, what happens here? Source code means your program codes. Source code simply here converts into binary code. Source code converts into binary codes. Binary code means system understandable language. Source code directly converts into binary codes. That binary codes submitted to processor, generating output finally. Okay. So what happens here? Except Java, in other languages here, source code converts into binary codes. That source codes converts into binary codes. After converting into binary codes, submitted to processor, generating outputs. See, example, C program is example, right? That source code converted to binary code, right? Source codes. Yes. CD mnref ls gdit express that it's exe file, right? Exe file contains binary format. That exe file express that exe binary code. Binary code. Natural language. This we can't understand. This system understandable language. Zeros ones format. It's a binary code. Right? It's a binary code. Okay. So source code converting into binary codes. Any language except Java. In any other language. Here, source code directly converts into binary code. That binary code submitted to processor, generating output. Okay, right? Yes, Java, what happens here? What is Java? Yes, in Java, what happens here? In Java, first source code. Yes, source code converts into byte code. There is one more code introduced in Java here. Source code converted to byte codes. Here. First of all, source code will convert into byte code here. That byte code converts into binary codes. binary code. That binary code submitted to processor, right? Processor only generating outputs. Okay, so what is happening here? Some intermediate code introduced here. Byte code is intermediate code. Some extra. Okay, right? Yes, here except Java only one step. Only one step. But in Java two steps. So first source code to byte code. Next byte code to binary code. So first step source code to byte code. Second step is byte code to binary code. Why byte code introduced in Java here? To make the Java is independent platform. To make the Java is independent of platform. Yes, next coming topic, independent of platform, we'll discuss. Okay, source code converts into byte code to binary code, then finally getting output, right? So there is the intermediate code introduced here. Source code converts into byte code to binary code, right? Okay, there are two steps in this. Two steps. Yes, how these two steps are working? Let us see. First, source code to byte code. Yes, we will do this here. Source code to byte code for this compiler. This in Java, compiler checking for all the errors. So this task by the compiler. This is by the compiler. Okay, compiler. So this is by the compiler. So this part is by the compiler here. This is by the compiler. This part is by the compiler. Yes, compiler check for all the errors. Compiler checking for all errors in Java. Yes, compiler checks for all errors. All errors. Checks for all errors. If no errors, then it generates Java compiler generates dot class file. Means bytecode generates bytecode generates bytecode. Just generating bytecode. Generating bytecode, right? Generating bytecode. Okay. So first of all, compiler checks for all errors. All errors. If no errors, then it generates one bytecode, right? Bytecode. Okay. Now bytecode to binary code. Who will convert this? Interpreter. So bytecode to binary code. Here, this is by the Java interpreter. As a part of JVM, this is interpreter. In JVM, this is interpreter. So interpreter taking bytecodes. Interpreter taking bytecodes. Line by line converting to binary code and submitting to processor generating output here. So bytecode to binary code by the interpreter. So this is by the interpreter. Okay. So what is happening here? Java first is source code. Suppose tested.java program. Yeah, this program yes will be given to Java compiler Java C. Java C means Java compiler. Java compiler taking this code here and checking for errors. If no errors, generating one bytecode file. Generating bytecode tested.class generates. After generating tested.class file, this bytecode given to interpreter. Same but that bytecode given to interpreter. Yes, in Java interpreter. Yes, Java interpreter. Yes, interpreter, right? Interpreter. Yes, Java interpreter is part of JVM. See, Java compile is not a part of JVM. JVM different, compiler different here. So compile is not a part of JVM, but interpreter is a part of JVM. Okay, so interpreter taking this tested.class file. See, first is source code test.java given to Java compiler, checking for all errors. If no errors, generating one .class file, means bytecode file. That bytecode file given to interpreter. The interpreter taking that bytecode file here, converting to binary codes. Yes, line by line. Converting to binary code line by line. Yes, line by line. Converting to binary code line by line and submit it to processor. Processor finally generating outputs. Finally generating output, right? Okay. So what is happening here? Errors checking by the compiler. That is first part. Errors checking by the compiler. Next, runtime, program execution. Yes, program execution by the interpreter. Program execution by the interpreter, right? Okay, so program execution by the interpreter. So there are two things involving here. So first of all, errors checking by the compiler. If no errors, generating one .class file. The dot class file is given to interpreter. Interpreter taking dot class file. Interpreter taking dot class file, executing, finally giving output. That is. Now Java depends on what? Java depends on what? Now can you tell me now? Is it compiler based or interpreter based? Now come to some conclusion based on my explanation. Based on my explanation here. Now Java depends on what? Is it compiler or interpreter based? Yes, can you answer this now here? I think you can answer now clearly. See, errors checking by the compiler, errors checking by the compiler, but program execution by the interpreter. That means what? Please. Yes, depending on what? Is it compiler or interpreter? Java depending on what? Is it compiler or interpreter? You sure? Okay, fine. Next others. I'm expecting answers from others also. Right or wrong, just respond. I'll correct. Suppose if you're giving wrong answer, I'll correct your answer. Don't worry. Yes, Java depending on what? Okay, interpreter. Okay. See what's happening here. First of all, program error checking, right? Suppose C language error checking by the compiler. If no errors, converting to exe file also by the compiler. In C language, only one thing, compiler. Errors checking by the compiler. If no errors, generating exe file also by the compiler. In case of Python, interpreter, checking error, if no error, execution. So checking error and execution both by the interpreter. Only interpreter will do that. But in case of Java, what happens here? Errors checking by the compiler, but execution by the interpreter. Okay, so compiler is responsible for the errors. Interpreter is for the run the program, correct? Means two things are involved here. Yes, two things involved here. See, C language error checking and execution both by the compiler only here. Error checking and generating exe file, compiler only. Suppose in case of Python here, error checking and execution both by the interpreter. But in case of Java, what happens here? Error checking by the compiler, but program execution by the interpreter. That means depends on both here. Java depends on both. This is conclusion. Java depends on both here. Depends on both. Okay. Java is a compiler as well as interpreter based. Java is a compiler. Java is a simple conclusion. Java is a compiler. Yes, Java is a compiler as well as interpreter based. Java is a compiler as well as interpreter based. So this is about Java. Okay, right? Yes, let us go to documents. See the documents. Yes, documents. See difference between compiler and interpreter. See, compilers and interpreters are used to convert from high level language to low level language to a topic. Okay, interpreter compile the differences. That 8 differences, all the differences very clearly. Same thing prepared in documents. So whatever we discussed, same thing it's in document here. Like interprets line variant, whole program at a time, gives result line variant, at a time outputs. Yes, only one error, interpreter all errors. Yes, it will not generate exe file. It will generate exe file. It always executes source codes, exe file. All the differences. Okay. See, Java depends on both the compiler as well as interpreter. See, in Java, errors checking by the compiler. If no errors, then Java compiler generates one dot class file. If no errors, then Java compiler generates dot class file. Yes, dot class file is a bytecode. Dot class file is not exe file. It's a bytecode file. Okay, so what is bytecode? What is exe file? We'll discuss. Okay, exe file dot class differences we'll discuss. Okay. Yes, next here Java runtime by the interpreter. Okay, see here. Yes, source code dot Java file. Yes, given to Java compiler, generating one bytecode file is dot class file. So dot Java to dot class between this Java compiler. Not dot class given to Java interpreter. So converts bytecode to binary codes and links with ways library generating output here. Links with ways library. This point we'll discuss. It's next topic. That point. Then generating output, right? So you can source code to byte code to binary code, then processor generating outputs. Two steps: source code to byte code to binary codes. Next here, source code to byte codes by the compiler. Yes, next byte code to binary code by the interpreter. So Java depends on both the compile as well as interpreter. Okay, right? So runtime is interpreter based. Okay, Java runtime is interpreter based. 1 second. Let me explain one point here. Yes, this. See, this is this point, 8 points. About 8th point here. 8 points. Interpreter based language. Don't have exe file. See, any language. Yes, you have to answer one more question here. Here I'll be asking one more question. Any language, runtime, any language, runtime is an interpreter based. Any language, runtime is an interpreter based. Yes, don't have exe file. Don't have the exe file concept. Okay. Yes, try to understand this point very clearly here. Yes, any language runtime is the interpreter based. That means program executing by the interpreter. Runtime is execution by the interpreter. Any program executing by the interpreter don't have exe file. See, Python script executing by interpreter, no exe file. HTML by the interpreter, no exe file. Any program executing by the interpreter don't have exe file. Okay, don't have exe file. Okay, right? Now come to Java here. Java language, runtime is the interpreter based, right? Java language, error checking by the compiler, but program execution by the interpreter, right? Java language runtime is interpreter based. Yes, Java language runtime is interpreter based. No question is. Yes, see, try to understand this point here. Any language runtime is an interpreter based. Don't have exe file. No, Java runtime is an interpreter based. Now question is here. Is there any exe file? Is there an exe file concept in Java? That's a question here. Concept in Java. Okay. Or yes, question is can we create exe file in Java? That's a question here. Can we create exe file in Java? That's a question here. Yes. Tell me, as per this explanation here, yes, any language runtime is interpreter based, don't have exe file. You program executing by the interpreter don't have exe file. Program executing by the interpreter don't have exe file. See Java program. See Java program runtime is interpreter. So Java program executing. Okay. So Java program executing by the interpreter. So any exe file concept in Java. So program executing by the interpreter. No exe file. Yes, in Java errors checking by the compiler, but execution by the interpreter. Java execution by the interpreter. Now question is there an exe file concept in Java? Say yes or no. Can we create exe file in Java? Now as per this point, here, can we create exe file in Java? Try to understand that point here. Yes, what is this point? Any language runtime is interpreter. No exe file. Runtime interpreter based, no exe file. Java language runtime is interpreter based. Java language runtime interpreter based. Any language runtime is interpreter based. Runtime interpreter based. No exe file concept. Java runtime is interpreter based. Now, is there an exe file concept in Java? Can we create exe file in Java? So, as per these points, can we create exe file in Java? Simple. Just try to understand that point here and give the answer. Yes. Any language runtime is interpreter based. Any language runtime is interpreter based. No exe file. Java runtime is interpreter. Since Java is a runtime is interpreter based, no exe file concept in Java. No. Answer is no. No. There is no exe file concept in Java. In Java, everything is dot class file. In Java, everything is dot class file. Dot class file is not exe file. In Java, everything is dot class file. Dot class is not exe file. Dot class is not exe file. Okay. Yes, same points mentioned document here. See, any language runtime is interpreter based no exe file. Okay, since Java runtime is interpreter based, no exe file concept in Java here. So can we create exe file in Java? No. Yeah, there is no concept of exe files in Java. Yes, in Java everything is dot class file. Java everything is a dot class file. Dot class file is not exe file. That's it. Okay. So all these basics clear. Now we can understand these features. Now you can understand Java features. Very clearly you can understand. Now in this Windows platform, now you can understand very clear portability. These features you can understand very clearly. Right? Yes. These features. Tomorrow will continue. Okay, tomorrow I'll finish all these features. Okay. So tomorrow all these features finishing here. After that we start programming. Tomorrow features finishing here. Next first half an hour. Yes. First half an hour. If these enough features. Next 1 hour. Yes, I'll take programming. I'll start how to install Java, how to set up Java. Next, how to write first program we'll discuss. Java setup and first programming we'll discuss. Tomorrow we'll continue. Tomorrow we'll start features. Okay. After finishing features, next we'll go for Java setup and Java programming. That's all. Yes. Any doubts? That's all for today. Yes. Any doubts, guys? Tomorrow also same link, same time. 8:15 same time and same link. Monday to Saturday classes. Right? Any doubts? Yes. Yeah, that's all. Right? Thank you guys. We'll continue tomorrow. Okay. Yes. We'll continue tomorrow.